Aloha! Today we'll be talking about 4 different types of fractions and how we represent them. Common fractions, improper fractions, mixed numbers, and decimal fractions. The 3 ways we will model these fractions are region, set, and line. Let's start by looking at the common fraction 3/4. We know it is a common fraction because the numerator is less than the denominator. Therefore, the fraction itself is less than 1. Jamie has a garden that is 3 feet wide by 4 feet long. That's 12 square feet. What is 3/4 of that garden? You can see on the long side, the garden has been divided into 4 separate sections. Count what is in 3 of those sections. 3/4 of this garden is 9, and that is represented by the area we've shaded in. This is a great way for finding equivalent fractions. Let's look at set as 3/4 of 24 eggs, or 2 dozen eggs. 24 eggs divided into 4 groups is 6 eggs per group. And if we counted 3 of those groups, 3 times 6 is 18. So 3/4 of 24 is 18. 3/4 of 2 dozen eggs is 18. Let's look at length as fishing line. You are going bottom fishing for some reef fish. You're making a leader for your fishing line that starts with a hook and has weights at every quarter foot from the hook. How far up the fishing line do the weights go? You can just count. 1/4, 2/4, 3/4. 3/4 of 1 is 3/4. Let's make an improper fraction. 5/2, 5/2. We know this is an improper fraction because the numerator is greater than the denominator. Therefore, it is greater than 1. We can represent this in an area model by drawing one hole and dividing it in half. Here we have 2 halves. That is not the same as 5/2. So we make another hole, divide it in half. Now we have 4 halves. That is not enough. So we add one more hole, but this time 1, 2, 3, 4, 5. We only need to add one more half to get 5 halves. As you can see, 5 halves is greater than 1. Let's look at set. We have 5 hamburgers shared between 2 hungry teenagers. They split each hamburger in half, and they each get 5 halves. For 2.5 hamburgers for each teenager. 5 halves is the same thing as 2.5. We can also see that an improper fraction is greater than 1 on a number line. Just count by halves 5 times and see where you land. 1, 2, 3, 4, 5. There we are at 2.5. 5 halves is the same thing as 2.5. Mixed numbers have 2 parts, the whole number and the fraction. Representing 2 2/3 as a region, we might think of cakes. 1 whole chocolate cake, 1 whole strawberry cake, and 2/3 of a vanilla cake. If each cake is divided into equal pieces, we have a total of 8 pieces, which is 8/3. So 2 2/3 is the same thing as 8/3. Representing mixed numbers as a set, let's take our dozen eggs. What is 2 2/3 of a dozen eggs? So we have 1 pack of a dozen, 2 packs of a dozen, and 2/3 of a dozen. So 2 2/3 dozen eggs are 12 plus 12 plus 8, which is 32 eggs. Looking at line, a yo-yo string needs to be 2 2/3 feet long, and you need enough string for 2 yo-yos. How much string do you need? Let's count our whole numbers first. 2 plus 2 is 4, plus 2/3 is 4 2/3, plus the other 2/3 is 5 1/3. Decimal fractions are similar to other fractions because they show parts of a whole. But they are different because decimal fractions are linked to the base 10 place value system. In a decimal fraction, the denominator is determined by place. In the decimal fraction 25 hundredths, we can see there is a 2 in the tenths place and a 5 in the hundredths place for 2 tenths plus 5 hundredths. A good area model for decimal fractions are the base 10 blocks. Think of your flat as a whole, divided into rods as your tenths, and now the cubes become hundredths. Shade in 2 tenths, which is 20 hundredths, plus an additional 5 hundredths for 25 hundredths. To look at decimals as a set, let's use a dollar. Cha-ching. A dollar has 100 pennies, and if you divide those pennies into 4 equal groups, there will be 25 cents per group. That is 4 quarters per dollar. 25 cents is 1/4 of a dollar. Well, there's a snapshot of representing fractions. I hope it helps. Ahui ho!